Hello everyone. Today, our group will introduce you to Object-Oriented Programming or OOP. OOP is a way of writing programs that is centered around objects, things that represents both data and the actions that can be performed on that data. It's important because it makes programs more organized, reusable, and easier to maintain. Many modern programming languages like Java, Python, and C++ are built with OOP principles. A real-world example of OOP is a human. A human contains data like its name, age, nationality, etc. It also has behaviors like talk, walk, or eat, etc. Together, the data and behavior form an object, in this case, the human.
So now we will move on to the second part of the discussion, which is procedural programming versus object-oriented programming. Procedural programming organizes code into functions or procedures that perform a specific task. It follows a linear flow with a clear start and end point. Variables can be local or accessible within a function, or it can also be global or accessible across functions. Meanwhile, object-oriented programming is a programming paradigm based on the name itself, objects. The main aim of object-oriented programming is to implement real-world entities into programming. Before OOP, programmers mostly use procedural programming. So here we have a sample code for procedural programming. In the procedural code, we simply create two numbers, which is 5 and 10. Which are stored in the variables a and b. The code then passes them to a function called add. The function takes the numbers, adds them together, and gives them back the result. Finally, we print the sum. This is procedural because everything is done step by step, using functions, and the data is kept separate from the behavior. So here we have the same code, but this time it is in the object-oriented version. So in the object-oriented version, we first create a class called calculator. Inside it, we put a method called add that knows how to add two numbers. In the main program, we make an object of the calculator class and then use that object to call the add method. This action or function is what we call instantiation or making a constructor. This is object-oriented because the data and the behavior are grouped together inside the object, making the program more organized and reusable. We think object-oriented programming is better because it makes the code more reusable since we can create many different objects from the same class without having to rewrite the code each time. It also makes the program easier to maintain and debug because the structure is more organized and problems can be fixed in smaller specific parts. Most importantly, OOP allows us to represent real-world objects directly in our programs, which makes it more natural and practical to model real-world problems in a way that it is easier to understand.
Now let's move on to the basic concepts of object-oriented programming. We'll mainly focus on class, object, and inheritance. But keep in mind, there are others such as encapsulation, polymorphism, and abstraction. So first, let's start with the example code of class. So a class is like a blueprint or a template. It describes what an object should look like and what it can do, but by itself. It's not a usable item yet because the most important point is that a class does not represent one single object, it represents the general idea of an object. In programming, we use classes to organize data and functions together.
As you can see, we have a class named smartphone, and inside this class are the attributes of a phone, such as the brand, the model, the screen size, and the battery level. Along with the attributes are the methods or the actions that a phone can make, such as make, call, charge, and display info.
Up next, we have an object. So an object is the actual instance created from a class. If a class is the blueprint, then the object is the real thing you can interact with. Objects have real values for their attributes and they can perform actions defined in the class. This is how we bring our code to life by creating objects from classes.
So we created two objects from the smartphone class using the new keyword, which are named as phone 1 and phone 2. So in this part, we're just setting it up as Samsung for the brand, Galaxy A42 for the model, 6.1 for the screen size, and 80 for the battery level. This phone 2 object, in this part, we're just using the objects and basically just displaying the info and trying to make a call to a certain number. And actually for the second object here, we use the charge method. So if we run that, it's going to run as this.
Lastly, we have inheritance, and inheritance is a way for one class to get the properties and behaviors of another class. This allows us to reuse code instead of writing it all over again. Think of it like family traits. A child inherits characteristics from their parents, but can also have their own unique features. In programming, inheritance helps us create specialized classes that still share common traits from a more general class. This makes our code more efficient and easier to maintain.
This is basically the same class that I showed you before, and we're just going to add 2 additional child classes to that same class. So the class gaming phone will basically have all of the attributes and method of the smartphone, this one, but also add its own unique attribute and methods such as the RAM, the GPU, and the play game method. So in the main class, we're just going to assign values to those attributes and call the methods in those classes. It'll look like this. So that's all for the introduction to OOP. Thank you for watching.